All right, welcome to topic number 20, dividing polynomials. And I'm going to talk, and after that, I'm going to talk a little bit about something called remainder and factor theorem. Okay, so division is very important. The relationship between dividing polynomial and finding zeros. If a polynomial function is not easily factorable, then dividing polynomial helps to identify the factors, either the divisor or the quotient of a polynomial function. Okay, it will actually help me to identify the factors. So remember, factoring is a division, but here we're actually going to do an actual division. Once the factors are identified, then the zero can be found by setting the factors equal to zero and solve for the variable. So perfect example. Okay, I'm gonna give you a perfect example that I already kind of mentioned before. Oops, hang on a second. Yeah, maybe like if I have, I'm gonna write this kind of same thing twice. Okay, if I have an x squared minus 4, we know this difference squared can be factored into x plus 2 times x minus 2. Okay, so if this is a polynomial function and I want to find the zeros, then I factor. Once I factor, I set each factor equal to 0 and solve for x. So what they're also saying is if I have this polynomial divided by maybe x plus 2, if I take a polynomial divided by its divisor, quotient divided by divisor, my answer will simply be x minus 2. So the relationship between dividing polynomial and finding the zero is if I have a polynomial that I don't know how to factor, maybe go through some sort of division, okay, then the quotient here, if the remainder is 0, okay, once I divide it, if the remainder is 0, that tells me that x plus 2 go into x minus 4 evenly. So is x minus 2, my quotient. So my quotient, my divisor are actually the factors of that polynomial. And we know this from things like, okay, 24 divided by 6 is 4, right? Evenly. Remainder is 0. So what we're saying is 24 actually has a factor of 4 and 6. Okay. So if I can find the factor, if I can divide and the remainder is 0, that means my quotient and my divisor are the factors of my 24 or my polynomial function. So once I can find the factors of my polynomial function, then I can set them equal to 0 and solve for x. And that's the way how we actually find zeros. Okay. That's the reason why here we need to learn how to divide. The pure purpose of division is to help us to see if the divisor is actually can become a factor to that polynomial function. Okay. And how do we know that? Based on the remainder. Okay. That's why here we're going to talk about remainder theorem here in a little bit. So let's go through the division. Okay. If you took Math 108 or beginning algebra, you probably seen polynomial division before. So here I'm just going to review for you. If you've never seen this before, that's okay. I'm going to use numbers. Okay, I'm going to use numbers. A lot of students learn long division differently. Okay, so I want to try this. I'm gonna go through this long division the way you might have seen it before. Then I'm gonna reword it in a little bit. All right. Dividend divided by divisor. 22 go on the outside. 4684 goes on the inside. All right. 22 cannot go into 4. So 22 got to go into 46. So my first quotient go on top of the 6. So normally we know 22 will go into 46 about 2 times, right? And after you roll a 2, you roll 44 right below 46. I do agree with that. But where did the 44 come from? The 44 come from the 2 times 22. So a lot of times students been taught, okay, you take 22 times 1, you take 22 times 2, and see which number is closer to that 46. Okay, and nothing wrong with that. But this problem is easy enough where students know, okay, 22 times 2 is 44. So once you roll the quotient, you multiply the 22 to get the 44 down here. Long division, we will subtract. 46 minus 44 will be 2. And you bring down the 8. And you start over. Now you say 22 going to 28 about how many times? 1 time. And when you wrote the 1, what you're really doing next is actually take 1 times the 22, which is 22. So long division, you subtract, you get 6, right? Bring down the last number and go through the process again. 22 will go into 64. All right. 22 going to 64 about what? 2 times? Because 3 will be 66, right? So we'll go into 2 times. 2 times 22 is 44. We will subtract. My remainder is 20. Okay. Now I'm gonna do exactly the same thing. I'm gonna do exactly the same thing, but I'm gonna say it a little bit differently. Okay. This is the way how we're gonna divide polynomials. Let's pretend every number, every digit is a term. So my dividend has 4 terms. My divisor has 2 terms. So if I have 2 terms on the outside, then I will deal with 2 terms in the inside at a time. So my first quotient go on top of the 6. So during the long division, my number 1 job is to cancel out the first term in the inside. Right now, the first term in the inside is 4. So I will take the first term on the outside, go into the first term in the inside so many times. 2 go into 4, 2 times. Once I wrote the quotient 2, then I will multiply all my terms on the outside. So 2 times 2 is 4. So since the 2 I multiply is the first term, then the answer I get, I need to put below the first term in the inside. 2 times 2 is 4. All right, 2 times the second term, 2 is 4. So I put below the second term. Long division, we will subtract. All right, my first term should always cancels out, right? 4 minus 4 cancels out. My second term, 6 minus 4. 6 minus 4 is 2. Since I have 2 terms on the outside, so that means I will deal with 2 terms in the inside at a time. So I will bring down the next term. So now I got 2 terms in the inside. So I will start the process over. So now the first term in the inside is 2 now. Not 6, not 4, but the 2. Because the 6 and the 4 are subtracted, you end up with the 2. So the first 2 is my first term in the inside. So I take the first term on the outside, go into the first term in the inside. How many times? 1 time. So the next quotient go on top of the following term, the 8. And once I wrote the 1 on the top, once I wrote the quotient on the top, then I will multiply both my terms on the outside. 1 times the first term 2 is a 2, so I put below my first term in the inside. 1 times the second 2 is 2, put below the second term 8. Long division, we will subtract. The first term, 2 minus 2, should always cancel out. All right, 8 minus 2 is 6. All right, so that's only 1 term. So now I bring down the next term and start my process over. So now the first term in the inside is 6 now. So I go through the process again, take the first term on the outside, go into the first term in the inside so many times on top. Then I go through it again. Okay. So that's the way how we actually gonna divide. So dividing polynomial using long division. Before writing out the long division, we need to check for missing terms. Remember, missing terms are referring to terms, okay, that are missing, and the reason why they are missing is because their coefficient is a 0. Okay. And the way we check for missing term is just go by the exponents. You want to make sure you see all the exponent in a polynomial. If you miss one, that means you have a missing term. Then the second thing you do is line up the position of the first quotient like I did here. All right, so your algorithm, your 6 things that you do. Once you line them up, use the first term on the outside, go into the first term in the inside. Okay, then you write the quotient on the top, like the 2 here I wrote on top. And then you take the quotient on the top, multiply all the terms on the outside. And then the answer you get, you put the product below the dividend that was on the inside. You subtract, then after you subtract, you bring down the following terms. And then start back to step number 1. Okay, we're gonna go through these 6 steps over and over. So consider the following polynomial division. Okay, before I even write it out, I want to check for missing terms. So my dividend, right? The exponent, the degree is 3. So if the degree is 3, that means the next one got to be x squared. Next one is x to the first. The next one is x to the 0 power over the constant term. So I do have all my terms in the polynomial. Your divisor, got to check for missing divisor. The degree of the divisor is 1. So 1 power and the next term should be no power, which is the constant term. So this example, I don't have any missing terms. So let's write it out. So all I'm gonna write out here is I'm gonna write the variable, but what I'm focusing on is a coefficient. So the x to the third is 1x to the third minus 1x squared minus 11x plus 18. All right, divisor is 1x minus 2. So what I'm going to focus on is its coefficients, okay? In the whole entire process, I'm not gonna write bunch x squared, x's, okay? Because they're all gonna end up being canceled out. So I'm gonna focusing on coefficients during the process. So let's line up my first quotient, okay? This is where if you watch YouTube videos, all that stuff, people do it differently, okay? And the way they do it does not make any sense. You got 2 term on the outside, so you deal with 2 term in the inside at a time. Okay, so 2 term cannot go into 1 term. 2 term got to go into 2 term at a time. So that means the first quotient got to be on top of the negative 1x squared. Okay. Now step number 1, take the first term on the outside, 1, go into the first term in the inside. How many times? 1 time. We wrote the quotient on the top. Step number 3, once I wrote that quotient on the top, I will multiply all my terms on the outside. So 1 times 1 is 1. See, I'm not saying x's, okay? That's too much, that's too confusing. That's why there's a little space right here. The space that I have is where the variable is supposed to go. 1 times 1 is 1. So I put below the first term. 1 times negative 2 is negative 2. That go below the second term in the inside. See, I left the space right there. The space are where the x to the third gonna be. So I'm not, so imagine me keep on saying, hey, 1x squared times 1x. You don't want to think that many things at one time. When once you lined up the quotient, all the variable follow straight down. 1 times 1 is 1, 1 times negative 2 is negative 2. Okay, once I wrote the product, then I would subtract. Long division, we will subtract. In first term, 1 minus 1 should always cancel out. Okay, this is tricky. You cannot say 1 here. This is second term is negative 1. So this is negative 1 subtracts negative 2. If you can say negative 1 subtracts negative 2, then you will put that in the calculator. That will tell you that this is really a negative 1 plus 2, which is positive 1. Negative 1 subtracts negative 2 is positive 1. All right, that's only one term, so I bring down the next term, -11 down. So you see, I keep my space, right? The space is where the variable goes straight down. So now so I start over the process. So now my first term in the inside is the 1. So take my first term on the outside, go into the first term in the inside. 1 going to 1 is 1 time. Where do I put that 1 time? On top of the following term of the quotient. Is 1 time. What kind of 1? Is a positive 1 time, right? 1 going to positive 1, positive 1 time. Once I wrote that quotient positive 1 on the top, then I will multiply all my terms on the outside. So positive 1 times 1 is 1 that go below the first term, right? When you multiply the first term, that goes below the first term. Positive 1 times -2 is -2, so that go below the second term. Long division, we will subtract. First term, 1 minus 1 always cancels out. Second term, be careful. This is a -11 subtracts a -2. This is not -11 minus 2. It's -11 subtracts a -2. And that should give you -9. All right, bring down my next term, which is positive 18. Bring down my last term, positive 18, and I start the process over. So now my first term in the inside is this -9. So take my first term on the outside, go into the first term in the inside. 1 go into -9, -9 times. And I put below, then I put above my last term, -9. See, the space is where the variable falls straight downward. Okay. So now once I wrote a quotient on top, -9 times 1, -9, put below your first term. -9 times -2 is positive 18, put below the second term. Long division, we will subtract. -9 subtract -9, cancels out. As a matter of fact, 18 subtracts 18. Same number subtracting, your remainder is 0. Okay. So when you finish the problem, then you go back to the very top of your first quotient and see that the first quotient is lined up under the x squared column. Okay, behind all these numbers is x squares. So my first quotient lined up with the x squared. So my next answer, my next quotient got to be positive 1x. And then the last term is -9. So my final answer is x squared plus x minus 9. Okay, no remainder. No remainder means that x minus 2 is a factor of this polynomial. So is the quotient. The x squared plus x minus 9 is also a factor of that polynomial function. Okay. Because this polynomial function cannot be factored. So if that polynomial cannot be factored, how am I going to find the zeros? Well, division is actually part of the process. Let's try another example. Check for missing terms. Before I write it out, check for missing terms. Degree is 3, 3, 2, 1, no power. So I'm good. All right, divisor, 1 power, no power. So I'm good. So 3x minus 1. So let's go through this process again. Okay, this is doing the same thing over and over. All right, line out the quotient first before we start. So 2 term on the outside go into 2 term in the inside at a time. So the first quotient must be on top of the 7x squared. Step number 1, take my first term on the outside, go into the first term in the inside. 3 going to 6 2 times. All right, once I roll the 2 on the top, I will multiply my 2 term on the, out on the outside. 2 times 3 is 6. Put below the first term. 2 times -1 is -2. Put below the second term. Long division, we subtract. First term, 6 minus 6 should always cancel. All right, subtract, be careful, this is a 7, okay? This is 7 subtracts a -2. 7 subtracts -2 is +9. All right, bring down the next term, +12 down. Start my process over. Now my first term in the inside is 9 now. So I take my first term on the outside, 3, go into the first term in the inside, 9. 3 go into 9, 3 times. What kind of 3? +3 times. So I put above the following terms, the following dividends, above the following dividends behind the 2. 2 is lined up with 7x squared. So the next quotient got to be lined up above the +12x. All right, once I wrote my quotient on top, I multiply the 2 term on the outside. So 3 times 3 is 9. Put below the first term. +3 times -1 is -3. Put below the second term. Long division, we will subtract. All right, that cancels out. All right, 9 minus 9 cancels out. 12 subtracts -3. 12 subtract -3 should be +15. Okay, bring down the last term, -5 down, and start the process over. Now my first term in the inside is 15. All right, so the first term on the outside go into the first term in the inside. 3 go into +15, +5 times. So that quotient should go on top of the last term. All right, once I roll the quotient on top, I multiply the 2 term in the front. +5 times 3, +15. +5 times -1 is -5, put below the second term. Long division, we will subtract. 15 minus 15 cancels out. -5 subtract -5. As a matter of fact, same number subtracting, the remainder is 0. So when I'm done with the problem, I look back up to the top and see my first quotient 2 is lined up with the x squared columns. So the next quotient, +3, will be lined up with the x column. So my final answer is 2x squared plus 3x plus 5. All right. Let's try another one. Okay, so this one got missing terms. Check this out. If you look at the dividend, right? 4, 3, but there's no 2 power. Okay, 4, 3, 2, 1, 0. You don't have a x squared term. So that term is missing. Why is missing? Because it has a coefficient 0. So we need that missing term as a placeholder in the long division. 2x squared plus 1, right? So degree is 2. So normally after x squared is x to the first power. I don't have it, so that means I also got another missing term on my divisor. So I'm missing a 0x to the first power. All right, so student asked me before, why do I put 0 in front of the x? Well, that's why they are missing. They're missing because the coefficients are 0 on the missing terms. All right, so once I found my missing terms, I can write out my long division. Okay, so for my dividend, 4x to the fourth minus 2x to the third. For my missing term, I'll always use a positive sign, okay? positive 0x squared minus 4x plus 2. For my divisor, 2x squared plus, okay, for my missing term, I'll use positive sign, plus 0x, then plus 1. So this problem might look big, but it's actually not as bad. I got 3 term on the outside, so I will need to go into 3 term in the inside at a time. So that means my first quotient should line up above the 0x squared. This is where my first quotient should go. Okay, so I'm gonna pause the recording for a minute, give it a try, see how far you can go. Okay, I'll give you a couple minutes, and then we'll come back, and take a look, see what you did. All right, let's give this a try. Okay, so first quotient gonna be on top of the 0x squared. So step number 1, take the first term on the outside, go into first term in the inside, right? 2 go into 4 2 times. So I put the 2 on top of the 0x squared. So once I put this quotient on top, I multiply the 3 term on the outside. So 2 times 2 is 4, put below the first term. 2 times 0 is 0, put below the second term. 2 times positive 1 is positive 2, put below the third term. Long division, we will subtract. All right, remember the first term always cancels out. 4 minus 4 cancels out. Negative 2 subtract 0 is still negative 2. All right, be careful. This is 0 subtract 2, not 0 plus 2. 0 subtract 2 is negative 2. So remember, I got 3 term on the outside, right? So I got to do 3 term in the inside at a time. So right now I only got 2 term in the inside. So I naturally bring down the next term. The last step 6 is always bring down the next term. So now my first term in the inside is the negative 2 now. So start the process over. 2 on the outside going to the first term in the inside. 2 going to negative 2, negative 1 time. All right, put on top of the negative 4x, the next term. All right, once you roll the negative 1 on the top, you multiply all 3 terms on the outside. Negative 1 times 2 is negative 2. Negative 1 times positive 0 is 0. Negative 1 times positive 1 is negative 1. Long division, we will subtract. First term always cancel out. All right, negative 2 subtract 0 is negative 2. Negative 4 subtracts negative 1. Negative 4 subtracts negative 1 is negative 3, right? Because that becomes negative 1 plus 1, which is negative 3. All right, bring down the last term and start my process over. So now my first term in the inside is negative 2. So I take my first term on the outside, go into the first term in the inside. 2 go into negative 2, negative 1 times. So that go above the last term. All right, multiply again. Negative 2 times 1 is negative 2, put below the first term. Negative 1 times 0 is 0, put below the second term. Negative 1 times positive 1 is negative 1, put below the last term. Long division, we will subtract. All right, negative 2 subtract negative 2, first term should always cancel. Negative 3 minus nothing is negative 3. 2 subtracts negative 1. 2 subtracts negative 1 is positive 3. So this time my remainder is not a 0. Okay, so when I'm done with the problem, I look back up to the top and see my first quotient is lined up with the x squared column. So that's 2x squared. My next quotient, this whole thing straight down, is lined up with the x column. So the next one is actually x, right? Negative 1x. But if you go all the way down, my remainder had 2 terms. So this first term, negative 3, is also lined up with the x column. Okay, so how do we write our answers? Okay, when I have a remainder. So it's almost like writing your answer like a mixed number. If I have a problem, let's say 8 divided by 3, right? 8 divided by 3, 8 over 3. 3 going to 8 two times. That's 6, right? Remainder is 2. Maybe not a very good example. Let's do 10. Let's do 10. 10 divided by 3. How about that? 3 going to 10 3 times. That's 9. Remainder is 1. So 10 over 3. You just think about division and write your answer as a mixed number. So if when you write your answer as a mixed number, it will just be the quotient plus, right? Mixed number is whole number plus a fraction. So when you have 10 over 3, you write your answer as a mixed number. You will say that's 3 and remainder becomes your numerator. Your divisor is still the same. So you get 3 and 1 over 3. Okay. So the way how we write mixed number answer after division is exactly what we're going to do here, except we're going to write a plus sign between the quotient and the fraction part, because mixed number is always a whole number plus a fraction. So my quotient is 2x squared minus x minus 1, right? That's my quotient. And we say plus the remainder, negative 3x plus 3 over the divisor. The original divisor was 2x squared plus 1. There you go. So that's how we write our final answer. Okay. All right. So hopefully you got part of the process. Okay. So this takes time. It takes a little bit of practice. Just looking at it. It's just practice. It's overdone. You do the same thing over and over for every quotient answer you got. Now, another type of division is called a synthetic division. Okay. Synthetic division is a shortcut of a long division. Is designed for a very, very specific type of problem. Okay. Based on the divisor. It is best if the divisor, okay, has coefficient 1 and is also raising to the first power. Okay. So this problem, I think, is the same one as the first one we did, right? Same thing as the first one we did. This is a perfect example of using synthetic division because my divisor has coefficient 1 and is also raising to the first power. Okay. So remember earlier when we did a long division, right? The remainder was 0. So what I said was, if the remainder is 0, that shows that this divisor is a factor, okay, of that polynomial. If this divisor is a factor of the polynomial, if it's a factor, then what I can do is set the factor equal to 0 and solve for x. Okay, so basically, if this is a brand new fresh problem, what we are saying here is let's pretend the divisor is a factor to the polynomial. If we pretend it is a factor, then we can set it equal to 0 and say x equal to 2 is a 0. Okay, we can pretend that x equal to 2 is a 0 to that polynomial. And that is what we needed as a divisor. Synthetic division is an upside down division. Okay, in the inside, we will write the quotient of the dividend. On the outside, we will write the divisor, which now we are pretending the divisor is 2. We are pretending x minus 2 is a factor. Therefore, we are pretending 2 is a 0 to the polynomial. So we will use 2 as a divisor. And in the inside, all I'm going to do is write the coefficients of my dividends. Okay, so that's 1x to the third, negative 1x squared, negative 11x, and then positive 18. Okay, this is how we will write it out in the first place. The first step, after you wrote this down, the first thing you do is bring down the first term. Then you take the divisor and multiply the number in the bottom. 2 times 1 is 2. You put the 2 below the following term. Okay, 2 times 1 is 2. You put that 2 below the second dividend. Syntactic division is opposite of the long division, so we will add. Not subtract, we will add. -1 plus 2 is +1. All right, so once I wrote another quotient down, then I will multiply again. Now the 2 will multiply this 1. 2 times 1 is 2. I put that 2 below the next term, below the next dividend. 2 times 1 is 2. Okay, so I'll put it right here. -1 plus 2, since that division we add, that will be -9. All right, once I wrote this quotient, then I multiply again. 2 times -9 is -18, put below the last term. Okay, since that division we will add. 18 plus -18 is 0. Okay, so think about this, okay? Division, when you take x minus 2, divide into about x to the third minus x squared. So what you're saying is when you take x go into x to the third power, your answer should be about x squared. When you're dividing, then what you're doing is you're actually taking the exponent downward. You're knocking x to the third power downward to the, knocking this exponent down. So when you go through the division one time, then the polynomial, your answer should not have exponent is one place downward. So x going to x to the third about x squared times. Okay. So what that means is this first quotient is no longer x to the third. It's actually 1x to the second power. So the next term is really positive 1x. The next term is -9, which is a constant term. So that means this right here at the very end of my syntactic division, that 0 is actually the remainder. So my answer is x squared plus x minus 9, remaining 0. Okay. So the purpose of syntactic division is the purpose of division, period, is to knock the exponent down of the polynomial function. Okay. So how do we go, so it's just like factoring, right? When I have a polynomial, I factor first so I can find the zeros. Factoring bring the exponent down from whatever the power were down to what? Down to the one I can deal with to solve. So the example I used earlier, the x squared minus 4, once I factored it, that's x plus 2 times x minus 2. Well, if you think about the exponent on what I factored, I actually take a quadratic down to a linear because the exponent on the factors are all x to the first power. So the purpose of factoring or slash dividing is to bring the exponent down of the polynomial function. All right, let's try another one, okay? Check for missing term. You got to still check for missing terms, okay? So you see the divisor, perfect, right? 1x to the first power. Since that division can be used here. All right, check for missing term. Make sure there's none here. 5 power, oh, supposed to be a 4 power here. So I'm missing x to the fourth power. 5, 4, 3, 2, 1, 0. So if you got missing terms, you got to actually fill in with a 0. So first quotient is 6, next quotient is 0. Next one is -2, and then +4, -3, and a +1. All right, since that division is an upside down division. So for a moment, I'm going to pretend my divisor is a 0. So once I solve for x, 2 is what I'm going to use as a divisor. All right, first step for synthetic division, bring down the first coefficient. Then we multiply. 2 times 6 is 12. You put that 12 below the next term. Synthetic division, we will add 0 plus 12 is 12. All right, once you wrote the quotient, you multiply again. 2 times the 12 is 24. Put below the following term. Negative 2 plus 24 is 22. All right, once you roll the quotient, you multiply again. 2 times 22 is 44. Synthetic division, we will add 4 plus 44 is 48. All right, keep going. 2 times 48 is 96. Oh, yep, 96. Put below the next term. Synthetic division, we will add negative 3 plus 96 is 93. Multiply again. 2 times 93, 186. Synthetic division, we will add. That will be 197. Oh, excuse me, 187. 1 plus 186. All right, I didn't write any signs because they're all positive, right? Because when I add them, it's all positive. If it's a negative, if my quotient is a negative, I will definitely write negative. All right, so remember now, the last number is the remainder. Okay, so when I take x, go into about x to the fifth power, that tell me that it's about x to the fourth power. So my first quotient now is 6x to the fourth power. The exponent get knocked down by 1. The next term, positive 12x to the third. Next term, positive 22x squared. Positive 48x. The constant term, positive 93. Right? I do have a remainder, so we write our quotient plus the remainder 187 over the divisor, original divisor, x minus 2. Okay, that will be my answer. All right, that's how we perform synthetic division. Okay, so remainder theorem. Earlier, this problem, the first example we did for long division, synthetic division, remember we had this polynomial function divided by x minus 2, and we found out both times the remainder is 0. All right, so when the function is divided by a factor, the remainder is 0. Okay, by the remainder theorem, what it's saying is, by the remainder theorem, we can evaluate the function. We can evaluate this function at x equal to 2. Then the y value will actually become the remainder 0. Okay, so what's happening here is, after we divide, when the remainder is 0, that means this factor, x minus 2, if I solve for x is equal to 2. So I can substitute this 2 back into the function for every x. Okay, then if I input x value, then my output will be the y value. So if the remainder is 0, that means if 2 is put into this function, then the y value comes out will be the 0, which is the remainder. So that proves that x equal to 2 is the 0 to the function. Okay, so when the remainder is 0, this is very important, then the number 2 we plug in is one of the zeros to the function. Okay, if you don't believe me, you can actually try it. Substitute a 2 into this function, put in a calculator, and the answer will be 0. And that 0, reconfirms that, hey, when the remainder is 0, that number I plug in is a 0 to the function. So what's a big deal? Why we keep on saying 0? Because remember, 0 of a function means find x when the y is what? When the y is 0. Okay. Now, factor theorem. So in a way, if I will grab this function, go to my table on the graphing calculator, beside 2, x equal to 2, the y value will be 0. So that 0 tell me 2 is a 0 function. That 0 also tell me the remainder is 0. All right. Now, looking at these functions from a different perspective, the factor theorem says, according to the factor theorem, if that 2 is a 0 of my function, if and only if that x minus 2, right here, x minus 2 is a factor. Okay, so if that 2 was a 0, that means I can write that answer as a factor. X minus 2 will be a factor. So by the factor theorem, if 2 is a 0 of my polynomial function, just like I wrote here, if and only if x minus 2 is a factor to that. Okay, just looking at it from a different perspective. All right, let's go over some homework questions. Okay, these are a lot of theorems. In the last two theorems, you got to think about what it's trying to say. It's almost like saying the same thing over and over. Okay, if it's if it's a 0, then if 2 is a 0, then x minus 2 got to be a factor to that polynomial function. If I use 2, if I take x minus 2, go into this polynomial function, my remainder is 0. Well, my remainder is 0, that tells me that x minus 2 is a factor. So therefore, 2 is a 0. If I solve for x, 2 will be the 0. All right, let's check out some homework. Question number 1. Consider the following polynomial division. Okay, so I kind of kind of make a picture of it for you already. So when you do this problem on the homework, I want you to make sure for number 1. Okay, look at this real quick. Enter the missing term if there's any. Okay, 5, 4, 3, 2, 1, 0. So dividend has no missing term, right? Enter the missing term for the divisor. 2, 1, 0 power. So there's no missing term again. So that's why I wrote this out. As you begin to write out the long division, remember I got 3 terms on the outside, so it will go into 3 terms in the inside at a time. So as you begin to write out the long division, including the missing terms, enter the term where the first quotient will be aligned at in the long division. So 3 terms on the outside going to 3 terms in the inside. So that means the first quotient got to be on top of 17x to the third power, which is basically what my picture is showing you. Okay. So number 4, I want you to enter the coefficient a. No variables. Okay. So work it out this entire problem and tell me what the coefficient a, what a is, what this coefficient a is going to be. Number 5, okay, if you keep on working it down, this d, tell me what the coefficient is for the d. I don't need you typing variable, I just need you typing coefficients. Okay, so tell me what a is, tell me what d is for number 4 and number 5. Tell me the coefficient as you work it out this entire problem. All right, number 2, synthetic division. Okay, enter the missing term for the dividend. And the missing term here got to be 0x to the 4th power. All right, 5, 4, 3, 2, 1, 0. So for number 2, I kind of already filled in for you. All right, so the missing term you have is 0x to the 4th power. So now, as a polynomial division is written in the synthetic division form, for number 2, enter the divisor. Okay, not the factor form. You got the set equal to 0, solve for x. So then that will be your divisor. All right, work it out and tell me what this coefficient b is for number 3. Okay, that's all you really have to do. And don't worry, we will do long division and synthetic division again at a different topic. Okay, all right, that will conclude this video on synthetic, long division, and both your remainder and factor theorem.